Hi everyone, I'm Yishi Zhang from University of Michigan. Here, I'm going to briefly summarize our paper on multitask peer prediction with task-dependent strategies. Consider the data annotation example, where we are soliciting labels from agents. Here, the question is how to reward agents to incentivize effort and truth-telling given their reports. Consider a flat fee mechanism, where we are paying everyone the same independent of their reports. However, this does not incentivize effort. We can use spot checking, which assumes some knowledge about the ground truth. However, the ground truth information can be expensive or even infeasible to obtain in a lot of cases. Here comes peer prediction, which works independent of ground truth. The idea is to reward each agent based on her correlations with her peers. In the multi-task peer prediction setting, tasks are IID sampled. Each agent answers multiple questions. Agents observe some signals on the assigned tasks, which represent her information about those tasks. And finally, agents play a strategy that maps from her signals to her reports. Especially, while truth-telling, the agent's reports equal to the signals. The goal here is to design a payment mechanism such that if everyone reporting truthfully, will maximize the expected payment. Our main contribution in this paper is to generalize the strategy space. Consider the question here is whether the tweet is related to politics. The signal SI and the report RI here are binary, yes or no. Suppose an agent answers n questions. A task-independent strategy is a random mapping from one signal to a distribution over her reports, denoted as theta I. And the agents are using the same theta I across all the tasks. In a generalization, task-dependent strategy is the random mapping theta D maps from a vector of signals over a distribution of vectors of reports. And because an agent's report on a particular task is not only depend on the signal of that task, but also on the other tasks. So we call this strategy task-dependent. Clearly, theta I, which is the space of all task-independent strategies, is a subset of theta D. And we want to emphasize that the theta D can be much larger than theta I when n is large. Task-dependent strategies are very common in practice. For example, while labeling, agents tend to change the frequency of reporting yes after observing a lot of yes. In the grading setting, it is very common for a grader to compare the quality of all different tasks before reporting. Our main contribution in this paper is that previous mechanisms all focused only on task-independent strategies. However, we propose a mechanism that can incentivize truth-telling among all task-dependent strategies.